Okay, so hello everyone. A very good morning to everyone. My name is Orhodip Mandal. I am from NIT Kurukshetra. Currently in my third year of BTech in the Department of Computer Engineering, and in this video I will be screencasting the Leetcode weekly contest 276, which is going to start in just 20 seconds. So wish me good luck, and I wish good luck to all of you also. Thanks. So let's start now. It's now going to start in 5, 4, 3, 2. It has started. It takes a bit of time to load initially. Yep, it has started. 1, 2, 3, 4. Four. We have 4 problems, but none of the problems are opening right now at this moment. So let's wait. Okay, so problem B has opened. So let's, okay, problem A is also open. So let's first get problem A. A string is can be partitioned into groups of size k using the following procedure. The first group consists of the first character, which is C. Okay, so the second group consists of second k characters, and so on. Each character can be part of exactly one group. Cool. For the last group, if the string does not have k characters remaining, a character field is used to complete the group. Cool. Note that the partition is done so that after removing the field character from the last group, if it exists, and concatenating all groups in the order, the resulting string should be S. Even the return string and denoting the composition of every group S has been divided to. Okay, so A B C D F G H I cool. Now A B C D F G H I J X X cool. Got it. So it's a very much easy problem. We have kind of string for auto for London for int I equals to 0, I less than n, int n equals to s dot length less than n comma I plus plus. Okay, so let's first check if we can take I characters or not. If n minus I less than k, okay, so then we have to do the if else for int I j equals to 0, j less than k, j plus plus string current. We have to define the current string here. String current equals to this current plus equals to s of j. Okay, control z, and also okay, has defined pushback, and also answer dot return answer. Here answer dot pushback current, and here in this case for int I equal to j equal to 0, s of I plus j. There should be, and 0 0 j less than n, j less than, for int j equal to I, j less than n, comma j plus plus current plus equal to s of j. And now for int j equals to 1, j equals to 0, j less than n minus I, comma j plus plus current plus equal to fill. Okay, I think that's it. And in both the cases, and in this case I equals to n minus 1, so I equals to n, so it will just break the loop, and in this case I should be equal to I plus equals to k. I plus equals to k. Yeah, this thing should be okay, I think. Good. So A B C D F G H I, this is code. Let's check. I think G H I J. I think this is a good test case to check my code. 3 and x. 3 and x. Let's now run this code. Finished. ABC JX. Okay, this is bad. N minus I less than k. If n minus I is less than k, for n j equals to 0, j less than j equal to I, j less than n, j plus plus df ghi jx. Okay, so n minus I in this case, should be equal to k. Okay, so this should be k minus n minus I, k minus n minus I. Code. Yes, cool. So let's submit this code. This is correct. Cool, accepted. Now let's move towards the problem B. You are playing a game with integers. You start with integer 1 and you want to reach the integer target. In one move you can either increment the current integer by 1, that is x equals to x plus 1, or I can double the current integer, that is x equals to into x. You can use the increment of operation any number of times, or can use the double operation at most max doubles times. Given two integers, target and max doubles, return the maximum number of moves needed to reach that target starting with 1. I think this is a BFS type of problem. Max doubles is only 100. Cool. So we can do something like this. So what can I do here? Since max doubles is only 100, okay, so we can just do 100 iterations in our string. Okay, for example, if target is equal to, for example, if target equals to 5, max doubles equals to 0, then it should be 4 only. And I think that we should go over we should reach a particular number and then try to increment it. Yes, I think that should be the case. Yes, like in this case, target equals to 10, max doubles equals to 4, so we can 10 by 2. Okay, so I think we can do something like this. In current equal to 0, current equals to target, while current slash equals to 2, while current greater than 1, current slash equals to 2, current plus plus. Okay, so these many max doubles we can get. Okay, so in this case, max doubles is 4. Initially x equals to 1, now x equals to 2, x equals to 4, x equals to 5, and then x equals to 10. Target is a long number. I think this is a good problem. I'm not able to solve it. I'm bad at maths. Max doubles is 2. Okay, so from 1 I can reach the half of that number. Okay, so if I do a map type thing, if I do a queue type thing, I think I can able to reach my number in number 100 steps. Okay, no queues. Max doubles is 4. So from the number 1 I can reach from the number 1 I can reach 3, so I can reach any number. So if it from the 1 I have to go about, I have to reach up till the number 10 actually. So I think I should go up till a certain point and then continue incrementing the number. Okay. Hmm. Current equals to current slash equals to 2 while current. Hmm. Okay. So I think from 1 I will let's say get to reach 2, then I should reach 4. From 1 I should get to reach 2 by 1 by using 1 max double, then to reach then reach 4 using second max double, then to reach 8 using the third max double, and then I have to from 1 I can reach 4, then one extra incrementing step and another step. So by this it will be 5 only. So if 10 is a multiple of 2, okay, so I think I should just continue to reach. Okay, I think I got it. I think I got this. Answer equal to 0 while max double, while max BOU while max doubles minus minus, and then target is greater than 1. I think I should just move in the reverse order. If target and 1, then answer plus plus, target minus minus, else target slash equals to 2, is target slash equals to 2, and this answer plus plus will be in both the cases. Answer plus plus. Okay, now answer plus equals to, if there is target, if target minus 1, max of 0, target minus 1. See out, return answer. I think this should work. We're going in the reverse direction actually. Finished. For the 50 case, answer is 4. Cool. For the 192 case, case, the answer is 10. Is it correct? No, it is 7. Okay, so from 19 I can go to, from 19 I can reach 18, from 18 I can reach 9, from 9 I can reach, okay, so why is it 10 actually? Yes, just a second. See out target answer. Target is 18. Okay, see out target confidence. Okay, so I have how many max doubles? I can actually use 2 max doubles. Okay, actually target is 19. Okay, got it. I got this, bro. I did max. I have to do max doubles, max doubles minus minus. I think that now this should work. 7, cool. 50, and the test case is 50, cool. 10, 4. This is 4, cool. Let's check my code once again. Answer equals to 0, and target is greater than 1. If target and 1, target minus minus, is equals to 2, and maximum minus, cool. Answer plus plus, cool. Submit. Cool, accepted. This is good. Let's now move towards the problem C. You are given a 0 indexed you are given a zero indexed to given a zero indexed 2D integer array questions where questions of I equals to, I think my OBS is recording this. Yep, 15 minutes passed. Where questions of I equals to points of I comma brain power I, the array describes the questions of an exam where you have to process the questions in order, that is starting from 0 and make the decision whether to solve or skip each question. Solving question I will give you points I points, but you will be unable to solve each of the next brain power questions. If you skip question I, okay, points I, brain power I question. Okay, got it. But if you skip question I, you will make the decision on the next question. For example, this: if the question 0 is solved, you will earn 3 points, but you will be unable to solve questions 1 and 2. If your question 0 is skipped and question 1 is solved, then you will earn 4 points, but you will be unable to solve questions 2 and 3. I think this is a DP problem. No, not DP. Yes, but it can be DP. Yes. Why not DP? So I think we can just run a recursive solution. Why not DP here? I love DP. I will do DP. आप क्या कर सकते हो? Factor of int DP of n and return DP of 0. Cool. Now for int I equals to n minus 1, I can equals to 0, I minus dp of I equals to a of points of I equals to a of points of not a of I 0. That is the point plus okay, p of I 0, p of I equals to, so either I, so my dp of I is calculating from the index I the maximum value that we can get starting at this index and ending at the other index. So if I is less than n minus 1, then it should be the dp of I plus 1 is 0. Cool. Okay, and now dp of I, and now current. So if I start in this scenario only, current equals to dp of I 0 plus I plus a of I 1. So I have to skip the next two things, 0, 1, 2, 3. Okay, 0 plus 2 things. If it is less than n, then it should be dp of I plus a of I 1, and this would be 0. dp of I equals to max of dp of I comma current, and then dp. So I think this should work. This is pretty cute dp. Okay, so this is bad. Question 0 and question 3. Okay, so what will be wrong here? Okay, this is correct. Let's print my dp states once. And I equals to my, okay, just to print here. Here dp of 0, so dp of I slash n. Let's check what my dp is printing here. From this state, the maximum I can get is 2. From this state, the maximum I can get is 4. That's right. Okay, so this should be plus I1, fi of 1 plus 1, I think. 0 plus 1 plus 2, plus 1 plus 1. This should be. Now that should be correct. 5. Cool. Okay, let's check the another given sample test. Custom test, custom data control, failure checks. It should be 7, it's giving 7. Submit my code. Okay, runtime error, cool, runtime error case. Runtime error, integer overflow. So I have to either long and shed just do it like this. We need a some type of input current for auto and x in field current pushback x and now a of pushback current as b pushback. Cool, a pushback current. Let's make everything LL. That's now everything current. LL I think. Yep. This should be compilation error. Max of dp of I, current should also be current. This is correct. Okay, so are there any chances that my code will get out of bounds type thing? I think no. Submit. Cool, accepted. Cool. Let's check my rank on 7. This is the last problem to get here. Okay, so people solve problem D also pretty easily. So this problem should also be done easily. You have n computers, you are given the integer n and 0 indexed array, integer array batteries, or the I battery can run a computer. You are given n computers, you are given the integer n and a 0 indexed array batteries, or the ith battery can run a computer for batteries I minute. Okay. You are interested in running all n computers simultaneously using the given batteries. Cool. Initially you can insert at most one battery into each computer. After that, at any integer moment, you can remove a battery from the computer and insert another battery any number of times. The inserted battery can be a totally new battery or a battery from another computer. You may assume that the removing and inserting process takes no time. Note that the battery cannot be recharged. Return the maximum number of minutes you can run all the computers simultaneously. I didn't get a sheet about this problem. Let's check what is this thing. You have n computers, you are given the integer n, battery is I. The battery can run a computer for battery is I minutes. Cool. You are interested in running all computers simultaneously in the given battery. Cool. Initially you can insert at most one battery into each computer. At most one computer is into each computer. After that, at any integer time moment, you can remove battery from the computer, insert another battery any number of times. The inserted battery can be a totally new battery or a battery from another computer. You know that the removing and inserting process takes no time. Note that the batteries cannot be recharged. Okay. Initially insert battery 0 into the first computer and insert battery 1 into the second computer. Okay, cool. After 2 minutes, remove battery 1 from the second computer and remove battery 1 from the second computer. Battery 0 first, okay, and battery 1 from the second computer. Battery 0 is now finished, and insert battery 2 instead. Cool. Note that battery 1 can still run for 1 minute. Yes, that is true. At the end of the third minute, battery 0 is drained and you need to remove it from the first computer and insert better D1 instead. Yep, yep, yep. By the end of the fourth minute, battery 1 is also drained, but the first computer is no longer running. We can run into the two computers simultaneously for at most 4 minutes. We return 4. Cool, got it. How many people solve this problem? Okay, no, not a lot of people. Okay. So this can be. So this is. I think this is a. I think this problem can be solved using binary search of int a pp pushback int n factor of ln a. Let's now do it like this: ln n equals to n. Okay, so now I think the maximum number of times will be at most 118 plus 5 only. So let's do it like this: 118 plus 5, and let's check if we can run all the batteries for at least 25 times. Also, I think I can sort all of them. If I sort them, it may be useful. Batteries by. Okay. Okay. Battery size is less than 10 raised to the power 9 actually, and battery slot length is less than 10 raised to the power 9. Okay, number of minutes you can run in computers simultaneously. Okay, so so what should be my initial thought process? Is it optimal to go for binary search? Because if I can check, we can run all of the computers for at least X minutes. Okay, and how will I check this fact? We can check this fact by inserting all the batteries into all of the computers once. Okay. So what we can do here? Mm-hmm. Mm-hmm. Hmm. Okay, so if I fixed that I will run each of them for X minutes, then the first one let it. So I can actually run all of them. If I let's say I will run all of them for X minutes. Okay, so the first battery, let's say, run for. Okay, so I think it is like a contribution type of thing, that there are two batteries and three batteries can contribute how much to them. First battery can contribute 2 to the first and second to the 1, 2 2 and 1 1. Cool, that's it. How many people solve this? Okay, so a lot of people solved it. penalty here, which is bad. Okay, so let's try to solve it fast. So can we do a binary search here? That okay, so if I do a binary search here, and n is and the battery slot length is always greater than equals to n, so the I will use the maximum battery to run for the whole period. Hmm. 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 So I think this is a cool problem. Let's think about it deeply. So there are n computers, 1, 2, 3, 4, 5, and there are some batteries which are of some length. So the highest battery. Okay, so just 1 second. Hmm. So let's say I run the first battery for a particular limit. Let's say x into the first computer, the longest battery. Okay. Okay, I think so. Let's say initially we run all of them using one only. Okay, so we actually now I have 3 batteries and the number of computers is 2. So initially I will just run them 1 and 1. Okay, cool. Now what I can do is that I can just run them 2 and 2, then I can just run them 3 and 3. Now since all the 3 of them have been finished, I can just use the third battery and insert it into one computer to make it 4, and into the second computer to make it 4. That's it. Okay, and now if this is the case, battery is equals to 1 1 1 1, and the answer is 2. So in this case I can run them for 2 minutes. That's cool. Now let's say if it was 2 3 4 let's say if it was 2 3 4 5 let's say if it was 2 3 3 4 5 and the number of batteries was 2. So initially what I will do is that I will run each of them for at least 2 minutes. Cool. Okay, I think so this one can be something like a sliding window type of thing. Initially I will run all of them for at least 2 minutes. Then this all is decreased by 1, so this can run at most 1 minute extra. 2 to 2. Then a sliding window of 3. Then there should be 1 1 1. Then another sliding window 2 3. Okay, so now no, I cannot take this sliding window, so remaining is 1 and 2. So I can just use 2 to contribute to 1 1 1. Okay. So I think I can just use them to, I can just use each battery. Okay. So they have to be run simultaneously. I forgot this one. Okay. So yes. So that's why this sliding window approach is good. Just sort them and use a sliding window of length. First use the first window of length n, then use the second window of length n, third window of length n. 2 3 4 2 3 3. Okay, so now since 2 1 1 1. Okay, 3. This is 0, this is 0, this is 1. Now I have 2 minutes left actually. Okay, so can I now use all of them to run? I can actually run approx of 3 minutes only. 1 and 2 are remaining. Can I do it better than 3? Let's see. 3 minutes. 3 3 3 1 2 1 2 2 3 minutes. Okay. 3 3 3 5 4 3 2 1 5 4 3 3 2 2. Let's say then I can have 5 4 3 3 2. Okay, so the first initialization has actually 3 minutes. Then in the next case I will have 2 and 1 minutes left with me and 3 and 2 minutes left with me. So I can just use the 3, 2 and 2 to make it another 3. 3 3 3 2 2 2. Cool. That is I dot length is less than -9. That's the cool. Okay. So I think now I can keep use this thing 3 2 3 2 3 2 3 2 3 2 3 2 3 2 3 2 3 2. Yes, I can run one of them for 3 2 3 2 3 and then 2 minutes. 3 and then 2 minutes. Cool. So just use the first sliding window and then use the second sliding window of length this thing. Yeah, okay, and then use the third sliding window 3 2 2 1. Okay, just keep on popping out elements until the size is less than k. So just use a second sliding window. I can insert 2, I can insert 2. Just insert them and just keep 1 in the second place. Cool. So now from 3 2 to 2 I can get 2 here. Now what I am left alone is 1 and 1 only. So this cannot be done anything else. 2. Okay. 3 2 2. So in this way this problem can be solved. How will we solve this problem actually? I think not a lot of people have solved this problem. No. Okay, so let's do this in this way. Priority queue. Let's try to use a priority queue. I have to use a mean priority queue. So let's copy my code. So let's copy that code of mean priority queue. PQ comparator. Control C. Control V. Priority queue. Start compare. Control X. First, let's see if I can run my priority queue inside this or not. This is actually a main heap actually. Compare LL and A, LL and B, return A greater than B. Sorry, A less than B. A greater than B. If I do this will just reverse the function of the main priority queue. Okay, so I can define these things, allow it and push back. Cool. So now let's see return 0. I can use my priority queue or not. Yes, I can use my priority queue here. PQ.push 1, PQ.push 2, PQ.top. Top slash on. Let's see what is happening here. PQ.top is 1, so it is mean actually. Okay. So now for LL I equals to 0, I less than n minus. Okay, firstly I should sort it. Actually sort everything. sort them in the reverse order, in the from max to min. So if is this okay? Yeah, this is okay. Cool. Now what I should do is that int I equals to 0, I less than n, for I less than, and what weight is the length of the first sliding window? This is n actually, and len equals to n dot length. I less than len comma plus plus I less than n. Okay, so now this is the first sliding window. Okay, for that first I have to insert all those elements. Okay, for a like I less than n comma I plus plus pq push I. Okay, no, I think I can do like it like this. If pq dot size is less than n, pq dot push I, else if pq dot top is greater than equals to, okay, I think I should take another vector where I will keep those extra elements after moving actually the other set. I should okay, so what I should take actually is that 5 4 3 2 2 in this case. Okay, 5 4 3 3 2. Okay, so what I can take is that, can I take 3? Yes, 3 3 2 1 3 2 3 2 1 2 5 4 3 2 2. Okay, so I can take this 3. First I will take this 3 for all those elements. Okay, then for the next part, can I insert 2 here? Okay, so I think I can just swap these things. Now this is 210. From now one element will obviously become 0, so that element will get discarded, and now two elements will be remaining, that is 2 1 and 2 2. Out of this I will choose the 2 only. 2 1 and 3 2. 2 1 and 3 2. So after that I will choose the 2 only. So 2 2 2. 3 plus 2 5. Okay, so that is the thing. 3 plus 2 5. Okay, now for the case 3 3 3, if it is 2 2. Okay, 3 3 3 if it is 2. Okay, for the case 3 3 3 if it is 2. Okay, if I run all of them for 3 minutes, then it will get drained. But I have extra 3 minutes remaining. Okay, so just run the firstly run. So can I let's first do a binary search thing. Can I do it for x? I have to run each one of them simultaneously for answer minutes. That will solve it. Okay, so everyone is solving it now. Okay, so if I have to run this for, let's say, answer minutes. Okay, so how can I run this for answer minutes? For running this for answer minutes, let's firstly take the maximum one, and then like in this case 5 4 3 2 2. For this case, what is optimal? It is always optimal to use a sliding window of length 3. Sliding window of some length 3. Okay, yep. And so if it is 3 3 3, then you first use a sliding window of length So 2, then we will use another sliding window of length 2. If it's the case 3, 3, 3, and if the answer is 2, are the batteries sound same? No, not same. If it is 3, 3, 3, then the value is 2. Then I should run each of them for. Okay, so if I have to check for 4, if I can do it for 4 minutes or not, then I will firstly do it for 2 minutes. Okay, so if I have to do it for 4 minutes. Okay, so let's do this like this. The extra minutes would have to be utilized. The extra 3 can be utilized. Okay, like this 3 can be utilized. Okay, these 3 can give 1 1 to each of them. Yeah, so just start its occurrence. So yeah, we start its occurrence, and like for the example of 5 4 3 2 2, 5 4 3 2 2. If I have to check if I can run for 5 minutes or not. Okay, so I have to check if I can run it for 5 minutes or not. How can I check it? For the first battery, let's say we run it for the sliding window of length 3 or 2. uh, let's say we run all of the batteries for 1 minute each. Okay, so 3 4 3 2 2 2. Okay, then we should run all of the batteries for again 1 minute each. 1 1 1 3 2 1 1 2 2. Then we will again run them for 1 minute each. Then 1 1 1. Okay, so let's do it like this. Let's take an example case like 5 4 3 2 2, and let's drop all of these things. What will initially happen is that I will just use 1 only for the 3 computers, then 1 1 1, then again 1 only for the 3 computers, and again 1 only for the 3 computers. So after this it will become 4 3 2 2 2, and after this okay, so control C. Okay, so after this will become 4 4 3 2 2 2. Okay, now after this would become 3 2 1 2 2. Cool. Now after this should become 2. This will become 2. This will become 2 2 yep, 2, and this should be 1. This is 1. This is 1. This is also 1. Now after this 1 1 1, and this will be 1 1 0 0 0 1 1, and lastly what should be it? 1 1 1 1 0 0 0 0 0. So I can utilize all those minutes. 5 4 3 7 7 10 12 13 14. How is it possible? Okay, so it's not 7 9 12 9 12 13 14 15 16. So initially I've done is 4 3 2, and here the number 3 into 1 2 3 4 5, and I was actually 15 minutes. So I think I've done something wrong here. 4 3 2 2 2 3 2 1 2 2 2 1 2 1. This should be 0 actually. Okay, 210, 210, 210, 210, um, 210, 22, okay, 21, okay, so no, 21110, 1, 2, 2, 1, 1, 1, 2. Now this should be 1, 1, 1, 1, 1. Now finally what I can take is that 1, 1, 1, 0, 0. Okay, so 3 5 is 15, 9, 12, 13, 14. So okay, what I have done, what I'm doing here, let's do it in a copy only. 5 4 3 2 2 5 4 3 2 2 4 3 2 2 2 3 2 2 2 2 3 2 3 2 2 2 1, then 2 1 1 2 1 1 2 1, then 1 0 1 1 1, then 1, then 0 0 0 0 1. Okay, so if the number of minutes are different, then we can utilize all of them. Let's take another example, 4 4 5 6, and let's say this is 3 actually, 8 13, and let's say a bit 5 5 5 4 4, and it is of 3 minutes, then 1 1 1 4 4 4 4 1 1 1 3 3 3 4 1 1 1 3 3 3 2 2 3, then 1 1 1 2 2 1 2, then 1 1 1 1 1 1 1, then another 1 1 1 8 13 18 8 13 18. What I've done here, 5 5 4 4, then the number of elements is 3 10 14 18. So first with 1 1 1 4 4 4 3, then 1 1 1 3 3 3 3, then 1 1 1 2 2 2 2 2 3 3 2 2 2, then 1 1 1 2 1 1 2, then 1 1 1 2 1 1 1 0, then 1 1 1 0 0 0. Okay, so I can take all of them, but if the number of minutes are same, okay, I think I don't have to use a priority queue here. I think let's like something else. And now if it is 3 3 3, 9 divided by 2 gives me 4 actually. Okay, so 9 divided by 2 gives me 4. Okay, so I can run each of them for exactly 4 minutes, and 4 divided by 2 gives me 2. Okay. Auto and x in a sum plus equals to x, then answer equal to sum by n, then n equals to n, sum by n, select return answer. I think this is correct. I am not sure about it though. Sum equals to 0. But if this is correct, this is a very bad problem. If this is correct, 2 3 3 3 4 2 1 1 1 1. That's good. 10 10 3 5. Okay, 10 10 3 5. Output math is 9 actually. So 20 plus 5 25 plus 3 28. Okay. Hmm. 10 10 5 3. Okay, so 10 10 5 10 10 5 3. Firstly, let's run all of them for 5 minutes. Let's say run all of them for 5 minutes. Cool. And now do this like a sliding window thing, right? 5 5. Okay, so 5 5 5 5 5 0 0 3. Okay, so then 5 5 3. Then I can run off them for 3 minutes actually. Yeah. So the new element matters actually. So 5 plus 3, I can run all of them for 8 minutes. Let's say if there was 10 10 10 9 5 3, and the answer was 4. So I can increase the first sliding window of length 4, then new length 4. 9 9 9 9 5 3 1 0. And run it for 2 minutes here. Then I can run it for 0 minutes here. So I don't have full batteries left. I'm not getting this. How to do this, bro? How to do this? I have no ideas now. How to solve this, bro? Yeah. Okay. Next number of minutes you can run all the m computers simultaneously. So the optimal thing is that choose the first key. Okay. 3 3 3 3 10 3 3 10 10 10 10 10 7 6 2. Then again 2 2 2 2 10 8 5 10 8 5 4. Then again 4 4 4 4 4. Okay, 7 8 9. In this case also I need to like this only. So, okay, so for example I was doing previously 5 4 3 3 2 5 4 3 3 2, and I got answer actually 5. So if I use 2 here, then 5 4 1 1 0. Then if I use 1 here, 5 4 5 3 0 0 0. Now the number of batteries left is only 2 2 3. Okay, but if you use in the reverse order, then I change to 3, then I can use the next 3 and the next 3. Okay. Okay. Then 3 3 2 2 1. Then I can use the 2 equals 2 2 2. how could I check for a particular minute? Check for a particular minute, let's say 8. Everything must run for 8 minutes, okay. Firstly, 8 into 3 must be listening to sum, okay. Now this total should run for 8 minutes. No bind search here. It's a priority queue type of thing only. Yep, priority queue. Priority queue should be the max min heap. Okay. If pq dot size is less than n, then pq dot push I, else okay, else while pq dot the top is less than a of I, and pq dot top, okay, is less than a of I, and now I'm going to pq dot top, pq dot top, pq dot push a of I, method is I, okay. So now for this test case, let's see 10 10 3 5 10 10 5 3. So if I have to check for 8 minutes, I will run each of them for 8 minutes. Cool. Okay. So one thing to notice is that if the sum of all the elements, so if anywhere between the sum is less than this thing, then I cannot run further actually. Let's do it like this. J plus 1 less than n, and then sum less than a of j plus 1. No, it is not like this thing. Okay, so I have to just consider the last 3 5 4 3 3 2. Okay, 3 plus 2 can give me 5 here. Okay, so I should combine these two things. 5 5 5 5 4 3. Okay, 3 plus 2 can give me 5. Okay, 5 5 4 3. Now 4 plus 3 can combine give me 7. 5 5 7. 2 2 2. Okay, so if I will check for a particular value, what I can do is that I can just pick this here. I will just pick the minimum, keep this set, pop out the minimum element, and add to it 6. 6, 3 plus 3, 6. Okay, 5 4 6. And this is 6. Okay. But this thing, this can be done. I think this can be done. pq dot push af now plus pq now plus afi return answer equals to pq dot top return answer 310. Let's see, finished 2 on 2. Let's copy this test also here. 8 answer, quick let's give the right answer for me. 333. Let's see. Okay, but in this case this thing will not work. 2 actually. Okay, so what I have initially done is that I have initially put 2 only, and that should give me 6. So I can just run this for 3 minutes. I can just run this for 3 minutes. This is not optimal. You have to check for X minutes. Okay. Let's do binary search here. X ln n ln answer ln n comma definitely equals to a dot size x comma n comma a. For index in a, sum plus equals to x, sum equal to sum plus equal to x. If sum less than answer into n then 0. Okay, now what I should do is that, okay, now everything should run for this much minutes. Okay, so how can I check this thing? Just to sort it also. So I will also just sort it also, and then sort it increasing order. Filter cool. Sum less than for it I equals to 1, I equals to 0, I equals to 0 and less than n comma I plus plus. Now for checking this, if it is less than this, okay, at most one battery can be inserted here. Only one battery can be inserted in a computer at a time. So only one battery can be inserted in a computer at a time. So this battery is inserted. Let's say it runs for 1 minute. Okay. Okay. So I think it's something like this. If the length of the maximum sliding window is greater than 3, if it's like 555,433, then I can run all of them for 5 minutes actually, and then again for 3 minutes, or I can do it better. 111,444. Okay, 54322. In this case I cannot do anything else. 31222. Sum less than plus 0, sum return 0. Now how to run this for run the first n should run for n minutes, x minutes, let's say. Answer minutes actually. Okay, so how to check this to run for answer minutes? Firstly, the highest battery should run in the first one for, let's say, answer minutes. Okay. Okay, should add to the first battery. Okay, let's do it in this manner. Okay, p equals to 1, then r equals to n minus 1. If f5 greater than equals to okay, so all of them must run simultaneously for this much minutes, not separately. Okay, so the problem basically reduces to finding the most, adding the most out of 3 elements. From 333 I can 3 is there. Is 1053. Okay. Some of this one. Okay, so this one for LL, when I equals to 0 minus 1 plus plus extra, then r equals to this one, this r equals to fi plus 2, r equals to n. Okay, then x equal to minimum of afr comma af comma required, and required equals to afi. So the required amount is answer minus afi max of 0 ll comma answer minus afi afr minus equal to minimum of afr comma required. No, that should be like this: if a of r is greater than equals to required, a of r minus equal to required, else 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 while required while r less than n and required minus equal to a of r plus plus. Okay, f r plus plus. Okay, while required greater than equal to 0, while required greater than 0, and then x equal to minimum of required comma a of r, required minus equal to x, a of r minus equal to x, r plus plus. If required while r less than x, if not required rec r plus plus. Okay, if required return 0, return 1. This may or might not work. Okay, 333 2 actually. Test case. Why is it in the test case 333? Okay, 2 and 333. 2 and 333. Now this is a complete test case. Compilation error. Leetcode x comma n comma a. Ln a equals to n. Ln equals to n. Subs are equal to n. R equals to n. R less than size. This is in the runtime error. 54 in type. 500. Okay, so maximum time can be 189 only 14. Let's make it only 14 maybe. Submit. Last executed input, if it is 1. If I run my code here, what is happening here? Give me runtime error. Okay. While required while. Okay, this should be the case. Cool, accepted. Finally I got this cool problem. So thanks for watching this. Finally I got problems, and let's check my rank. I think that would be pretty much a bad rank because all people have solved problem D up till now. B up should be at least 750. It should be around 700, I think. This was not a difficult problem, but I made it difficult by thinking a lot. So what I did, so now going over the solutions to all the problems. For the problem A, this one was a pretty easy problem. That is, you will be given a string and you will have to divide it into groups of 3, and in the last group it might or might not have enough spaces to fill the kth element. So in that case you will just add x. Like in this case, the length of the string is 9 and the group length is 3, so you can just put three elements in the first group, next 3 elements in the second, and the next 3 in the third. Now for this case the length is I think 10. A B C D F G H, yes, the length is 10 in this case. So in this case the last group will have only J, as you can see A B C D F G H I. So you will have two extra elements, that is K minus the length of the last group elements of field. So this is a simple implementation problem. Just you should keep a vector of to store your answer, and you will run your loop for this from I to n, and for the and you will keep a string of length current to store your current string of length k. Now if n minus I is less than k, that is this is the last group, and you cannot actually use all those elements present in your string to get the k elements. So in that case you will just run a loop from I till n minus 1 and just add all those elements, and then you will run a loop from 0 till k minus n minus 1, and for these many times you will add field. Otherwise you will just add k elements and you will do I plus equals to k, and finally you should do answer dot pushback current. So this is it for the first problem. Okay, so my rank is 711. It is okay, it's type rank. I could have done much better. Okay, so this one was another good problem according to me. So in this problem what you are given is that you will initially you will have 1 with you, and what you can do is that you can from your current element you can just increment your current element by 1, or just make your current element into 2, and just make x equals to 2 into x. Now this x equals to 2 into x operation can be performed only a max doubles number of times only, not greater than that, and but this increment operation can be performed any number of times. So how I solved it? I basically solved it in the reverse manner. I started from the target value and tried to reach 1. Now if the value of uh, target is odd, what I am just doing is that I am just doing an increment operation or a decrement operation. Since I am going from the I am going in the reverse manner, so my increment operation has become the decrement operation, and my into 2 operation has become the by 2 operation. Now if it is odd, I am just decrementing it, and if it is even, I am just doing by 2 in this. So this helps, and answer plus plus, and in the end if the target value is greater than 1, then I will just add this thing. Now coming to problem 3. Problem 3 was a pretty easy problem. It was a simple DP problem. So as you can see here, you will be given an array, and and let's say you will be given an array, and in this array each element will be a pair element, like in this case uh, and the first value will be the score you can get by using this thing, by solving this question, and the second value is the number of questions which you will have to skip after that. Like in this example for the case 3-2, you can get a score of 3 actually by solving the first question, but then you will have to skip the next 2 questions, that is 4-3 and 4-4, and then you can again start from here. That is, you can either skip or earn some points by solving that question. But if you solve that question, you will have to skip some questions, and if you don't solve that question, then you can continue from the next question. So you will have to find the maximum points you can earn. So I solved it using a simple DP what I did was that my dp of I will store the maximum value which we can get starting from that index I and going till the end. Now now the states of the dp are, if we don't use this, if we want to skip the current element, then it should be dp of I plus 1 only. Since we have skipped, so we will start from the next element and we will take the maximum value which we can get from the next element, that is I plus 1. But if we choose not to skip it, then we will use it, but then we will have to skip a of I1 element, that is I plus a of 1 plus 1. Then we can start only from dp of I plus a of I plus 1, and this question mark and colon are just to handle some the out of bounds things, that is if the next element is inside the range, then we will use that dp, otherwise we will just keep 0. And dp of I is just max of dp of I comma current, and finally it is dp of, we should print we should return dp of 0. Now coming to the fourth problem, which gave me a hell lot of pain. 3 wrong penalties and more than 40 minutes to solve it, though it was not that much of a difficult problem. So I think in this problem can be solved in this way. I solve, okay, so now coming towards the what is the problem. The problem is that you will be given some computers and also some batteries also, and you will and every battery cannot be recharged again. Now what you have to do is that you you have to find the maximum number of minutes you can run all of the computers simultaneously. Like in this case, you have uh, two computers and three batteries, and the charging values of the three batteries are 333. So so as you can see, they have run the first computer for initially for 2 minutes, then the battery remaining is, so sorry, they have run the second computer for 2 minutes, then the battery remaining is 1, and then they have inserted another computer of length 3 minutes and then run it for 1 minute, after which this battery is wholly completed. And then they have used another they have basically attached this one to this and ran this for 1 minute. So the total number of minutes is 4. I think that I will not be able to explain it properly, since I was also not sure about my completely confident about my solution, but it basically works for this problem. So as you can see, what I am doing is that I am just doing a binary search from 0, and the upper bound is 1 if 14, since the maximum number of minutes you can run all the computers simultaneously is the 10 raised to the power 9 into 10 raised to the power 5. It is 1 if 14 plus 5. And basically what I'm checking is that can we run all the computers simultaneously for at least x minutes. If we can do that, we will shift our range from L to X, otherwise we will change our range from L to yes we will shift our range from X to R, and otherwise we will shift our range from L to X. And this, and how to check this good thing. Now this good thing is that the best case would be that if the sum of all the elements is less than answer in 20, then we will just return 0. Otherwise we should always take the most active n elements and take the other elements to fulfill the required things. I just you can see now in this case, for the first element, and I have also kept a right pointer to keep track of the extra elements which I will add. And basically I am adding it, you can see from my code here. And lastly I am and if we cannot fulfill this condition, then I will return 0. Otherwise, if I can fulfill for all of the ends, I will return 1. So that's it from my side. I think Problem 4 was a good problem, but it was not that much a hard problem. I took so long. So that's it for this video. Thank you for watching my video. Thanks.